Hey guys, welcome back. Today I'm going to be doing a freeform video article. Wanted to cover a couple of things that were on my mind. I don't have anything that I'm reading off of, but I do have my wealth of information and knowledge and all the articles that have preceded this particular video article, I guess you would call it. So what I want to talk about right now is the state of the world and the way the universe works, my beliefs, and how I believe that everything is formed up and how everything fits together in the universe from the top to the bottom. And that's a lot to take in, so I'm just going to be doing this free form. I might have to redo this several times, so stick with me. But basically what's happening on planet Earth right now is we have some very evil forces. You could call them extraterrestrials, you could call them demons, interdimensional entities, whatever you want to call them. There is no question that there is some type of evil artificial intelligence slash extra-dimensional demon that has basically hijacked this planet. And to really understand what's going on, you have to understand that this is not just one single devil. You know, there's not just a single devil, but it really is an army. And this army is formed up in a pyramid triangle. And in popular terminology, this army goes by the name of the Illuminati. But it's not just the Illuminati. It's actually several literally extraterrestrial ET factions. Some of them look just like humans or very similar to human, and others look like reptilians, and then others look like greys. There's a lot of reports of different types of beings that are interacting with this planet in a covert way to basically hijack the very fabric of humanity and to subdue this planet and to turn us into slave farm, turn the population, the human population on this planet into a slave farm type of system, where we will be making their war machines, their spaceships, their advanced technology. At the same time, they will be feeding off of us, literally eating us. We literally feed the beast. Okay, so it's a multifaceted operation that's occurring, and it starts with social programming. It starts with chemicals being dumped into the food, into the water, and into the air. And it also involves secret societies that have different power structures that have infiltrated. To say the highest levels of this government that we know of is almost an understatement, because there's a whole operation behind an operation that controls the government and the people within the government. It's all being done covertly. The network is so vast, it's literally mind-boggling. Okay, so that's planet Earth. The point being is that we're farm animals, okay? And we will be eaten. We do die, whether you get eaten or you just die of natural, causes, or if the chemicals in the food and water and in the air, end up causing you to get sick, most likely cancer, and then you die of cancer, and then your body is definitely harvested. No matter how you die, most human bodies are harvested one way or another. Almost every single person that dies in the westernized world is mandatory for them to have an autopsy. When they have an autopsy, they remove all of your vital organs. There's no information as to where those organs go. And just like in Chinese medicine, organs of certain animals are, prized. I forgot the exact name. Organs of certain animals are not only aphrodisiacs, but they're sacred medicine, and they're coveted. So they're basically, they're expensive. They're a rare commodity, and they're expensive. So like if you eat the bladder of a bear, for example, it's something that you can hear about in Chinese medicine. Human organs, okay, are on the market in a galactic trade for biological material, and there are other species around the universe and in this galaxy that eat humans and eat human body parts, okay, as a sacred dish, if you will. And so when people die, their organs are harvested. There's children that disappear all the time. The Roman Empire has been in the business of harvesting humans since well before Christ. If you understand about how all roads lead to Rome, and how the Colosseum was a huge attraction where hundreds of thousands of people throughout the years would be gathered up from surrounding villages, and the men would be killed in war, and the women and children would be harvested and brought to Rome. And they would literally be fed and sold as food. Okay? So that's some very dark stuff. But the point being is that my personal belief, and if you look at all of spirituality, there is a consensus that there is an awareness that continues after your body dies. Okay? And so one of the things that I believe that was so profound in religion, and I'm going to use Jesus Christ because I do live in the Western Hemisphere of the United States, and Jesus, the Christianity is the dominant religion, so I grew up with a lot of Christian names and, vocabulary, basically. So, you have this idea that Jesus Christ didn't die when he was crucified, okay? That there was more to him. He was the Son of God, and that there is a heaven, and there's a hell, and there's an afterlife. These basic concepts, I definitely believe. Even though I think I'm a pantheist, I consider myself a pantheist, which I believe that the universe itself, in its entirety, is God. I also believe that there are angels and demons, and that there is what you would call a heaven, and there is the concept of hell, although both heaven and hell are maybe not exactly as they're described in biblical terms, and there's so many different nuance to those ideas. Hell burning at the bottom of the earth. There's definitely a dimension in reality that you could consider that to be hell. And then there's the idea of heaven, where this eternal happiness and light and blissfulness, that definitely does exist. And there are dimensions within the universe where I do believe that there is states of heaven. To associate those with the human form, I'm not going to get into, I'll just leave it at that for now. But I definitely believe in, a lot of the religious scripture. One of the things that Jesus Christ basically told us is that if you're a good person, when you die, you go to heaven, right? So your awareness doesn't end when you die. And there's other religions that talk about reincarnation. There's a lot of people who talk about we are learning how to live life, and then we progressively get smarter and smarter. There are some religions that think we started out as literally an atom, okay, and then we progressed from an atom to a microbe, and then from a microbe to a fish or a snail, and then we slowly progressed from a snail to maybe a lizard or a squirrel. Maybe we were a tree for a couple of million years, and then the awareness of each of those life cycles is somehow associated with some part of the universe. So even though if you're a tree, a tree is not just a single tree, but a tree could be an entire forest, right? So maybe that entire forest lived for millions of years, and then that entire forest died, and then there's some type of awareness or spirit or soul that's associated with the entity that was the life force that was creating that forest. And so when that forest finally did, wither and die or burn in a fire or whatever that consciousness that was aware of creating that forest, that life force, it's contained somewhere in the universe. And then so maybe, after a million years of trying to build a forest, and then, as things do, climate changes, the forest, dries up or burns or whatever, or gets harvested. That life force then picks up another body. Maybe it picks up a turtle or an elephant or a human or a lion or a tiger or a bear. Oh my. So maybe it picks up a human, and then you're a human multiple lifetimes, coming back over and over again, living, going through life, dying, and eventually you evolve. So you start off as an atom, and you see this natural progression, starting off as an atom, and you slowly progress, to more complex life forms, larger life forms. So usually smaller life forms don't live very long. The larger the life form gets, the longer it lives. So, elephants have a very long lifetime. Humans have a very long lifetime, especially for their size, and that's because the intelligence involved with the human, okay? So eventually, you evolve past that. So then the question is, well, what do you evolve past human or humanoid? There could be different levels of humanoids. There could be, maybe you go from being a human to being some type of advanced human, like almost an angel, where you have capabilities in another lifetime. That awareness that, you started out as an atom, that same awareness has grown and grown and grown, and now that same awareness that went through all the different incarnations of the different life forms and has been learning what life is, went through the human phase for many, many, many lifetimes. Maybe it'll come back as an advanced life form, where that life form that it picks up will definitely be a body, but it'll also, that body will have the capability to manifest things like be able to move from one location in space and time to another, and then you would say, well, maybe that's an angel or a demigod or some kind of, spirit like that. Or maybe it advances to the point where it literally will become a planet or a star, okay? So then the question starts to say, well, how could you go from being a human, okay, to becoming a star? And then, the universe is only expanding so fast. We do know new stars are being born all the time, and we do know that there's big explosions where it looks like stars in the universe are quote-unquote dying. Whether we can see what happens or not, we can't really tell, because after they explode, we can't see the luminosity that they once gave, and so we don't know what happened to them. They could be a star still, but just much smaller. They could, there's many, many questions which I will try to answer, because as I said, this talk is from the universe and everything in it from top to bottom. And I know that's a tall order, but I will try. And it might have to be several parts, and I might have to actually redo this 3 or 4 times, because, you have to edit it and fine-tune it and really, hone your message to be very concise, but also be able so that people can understand it. And that's what I'm attempting. So anyway, so you evolve. Okay, so there's some really bad things on the planet. Pretty much everybody accepts that they will eventually die, okay? And then the question is are you just this material meat bag that when you die you're just going to rot and you're going to be nothing, and that's it, that's nothingness? Or is there these concepts of an afterlife, heaven and hell? How could the universe actually maintain an awareness from a specific being throughout its entire evolution? And then how could that awareness then go from a humanoid body to, say, a celestial body, okay? And then I just want to mention right now, you could call that awareness, that whatever that energy is that's been inhabiting these bodies, starting out as, a snail, a squirrel, a chimpanzee, a human, a tiger, a lion, a bear, whatever you want to call it. Whatever that awareness is, some people call it spirits, some people call it souls, okay? Some people call the heavens, the stars above, the heavens. And what is in the heavens is souls. So in the heavens, you have souls, all right? So then there's this idea that your soul is this thing that keeps picking up bodies, and it can reincarnate, and it can go to heaven, and it can go to hell, and it can go through all these different evolutions. So you have the word heaven, which is like this beautiful place. And then also, if you look up into the stars, you call that heaven. And then in the stars, what do you call the stars? You call them souls, as in S-O-L, like the sun is a soul. And then, but you also have the word S-O-U-L, which is the spirit or the life force that drives the actual life itself. So, the life force behind the human, the person, the personality, the persona, the soul. See how they're all tied to each other? So in the heavens are souls, okay? In the heavens are stars. And I've been talking about the universe as a naturally occurring crystal core quantum computer, and that all the stars, the planets, the moons, the protoplanets, these are all naturally occurring crystal core quantum computers, okay? So that's basically saying that the universe... Okay, so I say the universe in its entirety is God, okay? So if the universe in its entirety is God, and this universe, this particular universe that we are in, is a self-contained crystal core quantum computer, and it's actually a black hole crystal core quantum computer in the universe above us, and all the black holes in this universe are crystal core quantum computers that create new universes, and then underneath in their universes that the black holes are creating, they create new black holes which create new universes, and then those black holes create black holes which create new universes, cascading universe, literally infinitely falling. So let's just start with the universe we're in. So there's a universe above us, okay, and there's a black hole, and inside that black hole is a new universe, and if that and inside that universe are new black holes which lead to new universe. So it's literally cascading. The single black hole that we're looking at in this universe, the single that one black hole, forget all the millions and trillions and uncountable numbers of black holes that there are in this universe, okay, forget all of those. Let's just look at one single black hole. In that black hole is the potential for a new universe. And in that universe, there's a potential for a new black hole, which leads to a new universe. So you could say that the black hole has the potential to lead to a cascading infinite amount of universes inside one single black hole. Okay, and then there's countless black holes in this universe. Now, then the question becomes, well, if you understand the way physics works and all this other stuff, there's this idea that an entity, some kind of physical piece of matter, an object, whether it be a statistical equation, whether it be, you know, a theoretical or a philosophical debate, the concept is that you're either expanding or you're contracting. Okay, so you're either expanding or you're contracting. Okay, now you look at that black hole and it's got an infinity of new black holes being created. Now you have to understand something. The universe we're in has a scale, okay? And at the very, very smallest part of that scale is called the Planck Scale. That's the smallest measurement that you can make in this universe. And that's based on the geometric, literally the geometric structure of the crystal core itself, the interaction of all the machinery, all the electromagnetic energy, the energy / dark energy interacting with each other, creating mass, creating energy, creating black holes. This all has a very distinct structure, and at the smallest points in this universe that we are in, there is a finite structure where it cannot get any smaller, and that point is called the Planck Scale. But inside the black hole, remember, we're still looking at this one, let's call it just Singularity A, okay? Inside Singularity A, which is a black hole, inside Singularity A, the Planck Scale is much smaller than the Planck Scale in this universe. Okay, so now what does that mean? So if you have everything, let's just say everything can be no smaller than a foot. Okay, so you know, you take the foot, you take your two hands, you touch them together, you move them out about 6 inches on one side, 6 inches on the other. You got a foot, right? You hold your hands out. Okay, so nothing can get smaller in this universe. Nothing can get smaller than a foot. That means that all of the electromagnetic waves, that means that all the interaction of the particles cannot get smaller than a foot. That means that the rate of time can only be as fast as the matter and energy can interact within the distance of 1 foot. Now, inside Singularity A, if that new geometric space-time is smaller, and if the Planck Scale is smaller, what that means is that, say inside Singularity A, the Planck Scale 6 inches, okay? What that means is that time, ultimately what that means is that time can operate much faster than the time that we experience in this universe, okay? So what that means is that, let's just say you're looking at Singularity A, and it just created its own universe, and it's going through, there's a phase where everything's just pretty much white hot plasma, and then there's this, slowly there starts to become some interaction, things start to cool down and solidify. You have all the different, basically properties, the geometric structures within the crystal itself start to form into very distinct gradients and structures. They form their 10 distinct pressure gradients, and then they start to interact with each other. They start to create what is known as surface area, and then that's when you actually start to get solidification, where new round objects can start to form out of this murky plasma that has no real form. It's just just a big ball of energy. Once it starts to coagulate, I guess, if you will, and the structure itself defines itself into the 10 distinct gradients based on mathematics, geometry, and logic. Okay, it does this because that's the natural, easiest. Everything's about efficiency. So the structure within the black hole, it comes to a point where it literally finds the best, most efficient equilibrium, and that is divided into 10 structures. Because of geometry itself, there's only so many ways efficiency can form. So, and based on efficiency, then you have logic, and then you have this distinct universal construct that forms. It's just a natural occurrence based on pure efficiency, okay? Efficiency, logic, geometric, mathematical equations create this standardized structure. And within that standardized structure, you start to get this solidification occurring, where you have the pressure gradients basically divide into the greater portions. So you have the macro and the micro within this universe, and then they start to interact with each other. So it goes from a singularity, it goes to a duality, and then there's a trinity, and from there you have infinity. Okay, that's I'm going to leave it at that, because that's the simplest way I can explain it. I could, you could go into math classes for 50 years, and it would still be very difficult to explain. But anyways, so you have the singularity, then you have the duality, then you have the trinity, which leads to an infinity. Okay, so our Planck scale is 1 foot. Inside singularity A is 6 inch. The Planck scale is 6 inches. So that means after, let's say, millions of years in our universe, okay, and it started to form up, all of this mathematical logic starts to crystallize and to literally form up into the universal construct. Okay, once that happens, every million years that we experience, I'm just rounding these numbers off. They could be, it's a case-by-case basis. There's so many other factors involved. It's called modulation, and we're just going to remove the idea of modulation right now and just stick to some solid concepts, which, we're using a foot, okay? So, and then 6 inches. So, a million years in our universe can pass. Inside that universe, 2 million years could pass. Potentially even much more. Okay, so what that means is that inside the new universe, inside singularity A, inside this black hole, we can experience a million years. Potentially it could experience 2, 3, 4, 5 million years. Say 10 million years in our universe goes by. 100 million years went by. Not only that, once that universe starts creating new black holes, okay, inside singularity A, once inside singularity A, once new black holes start creating in that universe, it's the exact same thing. So when a million years goes by in this universe, 2 billion years goes by in singularity A, and let's call the new black hole we're looking at inside that universe singularity B. Okay, so when a million years goes by in our universe, in the base universe that we're talking about, and don't forget, there's an infinite amount of universes above us, okay? And there's potentially an infinite amount of universes within this one black hole, singularity A, okay? And then now we're inside singularity A. We're looking at singularity B, okay? So in base reality, the reality we're in, when a million years goes by, inside singularity B, 1 trillion years could go by. And inside the universe is inside singularity B. Okay, let's look at singularity C. Inside singularity C, okay, when a million years in our base universe occurs, inside singularity C, 1 trillion years or 1 billion years could occur. Okay, just keep it rounded off, right? So the point being is that time starts increasing faster and faster and faster once these new crystal cores actually start to coagulate and to actually solidify into their 10-dimensional structures. Okay, so And then inside each new black hole that's created, time progressively gets faster and faster and faster. Now here's the trick. So let's go back to singularity A. The universe, we're in the universe, our base reality, and we're looking at the black hole, singularity A. Okay, its time is so much faster than ours, okay? So it goes through its Big Bang, it goes through its solidification, all of the... Okay, so this is where we're at right now. And this is where the information I'm about to explain to you will lead to this concept. So the concept that I'm going to tell you right now is this. Motion of matter equals gravity, which equals energy, plus about 10%. And all that means, the only thing that you have to take away from that statement is that every universe has the potential to be expanding. And not every universe does expand, but the vast majority of them do expand. Statistically speaking, 80% of all universes are in an expansion phase, or in a 20% are definitely in expansion phase, 60% are in a static or ever evolving phase, which means they are expanding, but 20% are expanding very fast, 60% are expanding at a standard rate, and then there's probably about 20% that are shrinking, okay? And of the 20% that are shrinking, there's probably 5% that are shrinking fast, and then there's probably about 2.5% that are shrinking really fast. And it's the same thing with the 20% that are expanding. Of the 20% that are expanding, there's probably 5 or 10% that are expanding really fast, and then there's probably 2 or 3% that are expanding basically infinitely. So that's the two poles. You have to think that those are the two poles. Those are the two opposite ends. You have expansion and you have contraction. And within the mathematical, geometric, multidimensional structure of space-time, those poles, they come into account. There is an idea that the quantum crystal cores have 8 geometric structures. Okay, they're 8-sided crystals, or there's 8 dimensions to the crystal. Now, that would be fine, but they're not static. Nothing in the universe is static. Nothing in the multiverse is static. They have to be tied to a pole. So you have 8, and then you have 2 poles. What does that equal? That equals 10. And there's all other kinds of reasons behind the numerology and the mathematics, but your prime number is 10. 9 is contraction, 11 expansion, 10 is your reference point. And that is the key to the way the universe works. So you've heard of 11. I'll give it 110%. The universe is expanding. Motion of matter equals gravity, which equals energy, plus about 10%. That 10% brings you up to 11. Okay, you have a surplus. You have 11. That's expansion. Okay, I'll give it 110%. That's just a commonly said kind of, that's something that's just commonly said. There's a reason behind it, and there's esoteric knowledge that that particular saying comes from. People aren't even aware of this, but it is a universal law that there is 110%. That's the way the universe works. Okay, so going back to that singularity A that we're talking about, let's assume singularity A is growing, okay? And inside singularity A, singularity B is growing, and inside singularity B, singularity C is growing. Now, each universe can grow, and when it grows fast enough, eventually, it has the potential to spit matter and energy up outside itself and start to grow mass around itself. This mass might start out as a star, or as a what you would call a solar system. Eventually, that solar system will grow larger and larger, and more matter and energy will come out of the black hole, because inside the black hole is an infinity of new energy being created all the time. And not only is that infinity of energy going down in density and in energy, there's also an excess of energy that is coming up from each level within that black hole. Each new dimension that's created, every single new black hole has the potential to grow and expand, and if those black holes inside the black hole are growing and expanding fast enough, they have the potential to spit matter and energy back up into the universe that they're residing in, which then grows that universe, and then that universe has the potential to spit matter and energy back up, which grows the universe that is residing in. And so life is infinity divided. You have the macro and the micro. You have the infinity and you have the nothingness. You have the two poles, and this is true from the top to the bottom of the universe. And so the way we look at the universe right now, it might be very hard for people to understand. It might hurt your head. But when I tell you that life is infinity divided, that really is the truth. There's an infinity of energy going one direction, and there's an infinity of energy going in another direction. The up force and the down force. And this is... you also have like, Sauron's eye in like Lord of the Rings, where it's these two pillars, okay? And they seem, there's a fire burning in the middle of these two pillars. And if you notice, the fire is pulling out, it's pulling outwards. And in the very center of those two pillars is this blackness, this absolute nothingness. But then this absolute nothingness is then all of a sudden surrounded by this burning hot energy. And there's another saying from Star Trek, it's time is the fire in which we burn, okay? And so this leads back to the idea of infinity, infinite time, infinite energy, and, this cascade of energy falling perpetually higher and higher into newer and denser energy states. At the same time, it is getting lighter and lighter, and literally becoming lower and lower energy states. So you have the up force and the down force, okay? And these are the poles. These two poles literally pull energy out of nothingness. Now, this doesn't make sense. It's magic, okay? So basically what we're talking about is the universe uses magic, okay? And, one of the things that you could say is, well, have you ever locked your arms around another person and danced? Have you ever noticed if you lock your arms, your elbows, around a friend and you start dancing in a circle, you can start spinning faster and faster with less energy, okay? And if you have a whole group of people and they all lock their arms around each other and they start spinning in a circle, you will notice that with very little effort, the entire group can rotate faster and faster. Obviously, there's limitations to how fast you guys can, rotate, but it takes a lot less energy when you have a group of people or another person and you lock your arms around somebody and you start moving. There's this thing called gravity assist. This is the way the universe works on a macro and a micro scale, where you can actually come together as either a duo or a group, and you can use each other's energy to actually assist each other, and you can move faster and faster. So that's where you have the galaxies forming up, you have the solar systems forming up, you have literally the machinery of the cosmos is being guided, okay, with intelligence, okay? There are intelligence nodes, there are crystal core quantum computers that literally guide these celestial objects to form up into these spiral galaxies, and they all start spinning around the central black hub, the central black hole at the center of galaxies. Some people call that the central black sun, okay? But other people call that the central black hole, okay? It doesn't matter. Whatever it is, that object, that pole at the center, that pole is a gravitational pole that the rest of the planets, that central pole is a pole for the rest of the planets and celestial and stars, I should say, for the rest of the stars in the galaxy to use as a central point for them to start rotating around. And then in that rotation, they all use each other's gravity, okay, in a way where they actually can rotate faster and faster. They do create gravity. They swim themselves. The stars, you can say that all of the stars in the universe are swimming, okay? They're definitely creating some energy. They're using their electromagnetic energy. They're shining, and they're shining harder in one direction. And because of the way the universe works, when they use that electromagnetic field and they create it harder in one direction, it means that they can move into that direction faster. So that means that they can actually move themselves. It takes a lot of energy for them to move themselves, but they can move themselves. So the whole trick is that they all get together and they all say, okay, I'm going to move this way, you're going to move this way, and we're going to use gravity assist. As I move this way, you come up along the side of me, and because you're going to be caught into my gravitational field, you're going to start falling faster and faster, and then what's going to happen is, then you're going to be in front of me, and I'm going to be slowing you down a little bit, but I'm also going to be speeding up because you just flew past me at a certain speed. So now you're going even faster than you would have been able to. And then what you're going to do is I'm going to use that speed, and I'm going to use my gravity, and then I'm going to spin past you. And then I'm going to go faster. And so they all start rotating around each other, consciously talking to each other as intelligent celestial objects, literally dancing the waltz around the central hub. Okay, and they rotate faster and faster and faster. They start moving out away from the center. As they start moving out away from the center, they increase their energy, because remember, motion of matter, it's over the dark energy field or the Higgs field or the piranha or the ether or whatever you want to call it. There is definitely a field, because remember, this is all happening inside a crystal black hole. This is all happening inside a crystal core quantum computer. The entire universe is not in empty nothingness. It's inside a giant crystal core quantum computer that's giving the universe itself the Higgs field or the piranha or the ether or the dark energy field. It's giving the universe this dark energy field that is a crystal structure matrix. And as this energy is flowing through this crystal structure matrix, it's able to spin faster and faster. And you have to think of it like a piezoelectric effect. If you ever rub your feet on the carpet, you generate an excess of energy. You touch the doorknob, and there's like a 1,000,000 volt little tiny arc of energy that bursts from your finger to the doorknob. Okay, so you rub your feet on the carpet, and you touch the doorknob, and there's like there's a little tiny micro spark of like 1,000,000 volts that goes from the tip of your finger to the doorknob, and it only lasts like literally a fraction of a second. But that energy was generated from you rubbing on the carpet. It's the very same basic principle of when these cores are moving through the crystal structure of the universe, and they start to move outwards away from the central hub, and they start to move faster and faster, and they all team up and they use gravity assist. And while they're doing this, they're going through their entire life cycles of expanding, getting huge, okay? They create a huge amount of mass around them. And then when the time is right, depending on their whole rotation, say the central black sun or the supermassive black hole at the center of the galaxy is also spinning around other galaxies in a huge galaxy cluster, okay? Say it's moving, you know, in one direction. Say it's moving to the right, okay? And you're looking at the galaxy from the top. And I have to explain this because you will be able to visualize exactly what I'm talking about, okay? So if it's moving from the left side of your screen to the right side of your screen, and you're looking at it from up top, and it's rotating on a counterclockwise rotation, okay? So as it's going from, say, if you're looking at it like it's a clock, and 12 o'clock is the direction it's moving, 6 p.m. is basically the direction that it's coming from, okay? So at 3 o'clock, 3 o'clock is when the stars are all moving at their fastest, okay? Because the central black hub is moving in the direction towards the right, so at 12 o'clock is the same exact direction that the galaxy is moving in. So all the stars within the galaxy at 3 o'clock, they're moving their fastest. That's called peak upswing, okay? That is called peak upswing. And so they move at 3 o'clock, they're moving their fastest. As they rotate further towards 12 o'clock, and once they get towards 12 o'clock, they're moving at about the exact same speed that the entire galaxy is moving in. And then, after they pass 12 o'clock, and they get to 11 o'clock, 10 o'clock, 9 o'clock, they start moving slower through the dark energy field. Remember, we're talking about this galaxy is moving through a liquid crystal medium, okay? So as everything is rotating and moving from the left side to the right side, and 12 o'clock is the direction that the galaxy is moving in, and as those stars start moving from the 12 o'clock position to the 11 o'clock position to the 10 o'clock position and to the 9 o'clock position, they are now moving in what you would call a downswing. They are moving slower. They are moving at 9 o'clock on the dial. They are moving slower than when they were moving at 3 o'clock on the dial. And so this whole cycle here, when the galaxy is rotating and moving from left to right, and you're looking at it from the top to bottom, and it's rotating in a counterclockwise direction, from the 6 o'clock position, at 6 o'clock they're moving at about the same speed as the entire galaxy. And then as they're moving from 6 to 5 to 4 to 3, and actually 2 and 1, and all the way back to 12, that is the upswing, okay? They are moving faster in the upswing, and then they are moving slower in the downswing. So depending on their whole cycle and how they're moving, and of course stars aren't all just rotating around the central core of the galaxy. They're in star clusters, just like the galaxies in a galaxy cluster. The stars are in star clusters, and then the stars could be in a binary system, and then within that binary system, there could be all kinds of other rotations of planets and stuff, and this is where you really start to break down the celestial mechanics. And, you know, this galaxy's thought to be, I forgot the age of the Milky Way galaxy, but let's just call it 10 billion years, right? 10 billion years is a long time, so it's probably a lot older than that, but I'm not going to, you know, try to, you know, buck the trend on this particular talk on the age of things, because all we have to say is it's really, really, really old. Okay? Now, there's something I want to inject right here. And since I just covered this particular topic, okay, I'm going to inject this right now. Motion of matter creates gravity, which creates energy plus about 10%. So as you're going through the upswing, okay, let's just keep things really simple, and let's not get into the celestial mechanics of the star clusters and the binary star systems, and then within the binary star systems there could be planets that are so large that they also affect the way that the wobble of the star compared to the way it's rotating through the star cluster, compared to the way that it's rotating through the galaxy, compared to the way the galaxy is rotating through the galactic cluster, and how the galactic cluster is rotating around the entire universe. Okay, so that's how complicated it gets, right? You're talking about some serious, you know, equations. But let's just keep it real simple and pretend that everything is, kind of narrow it down to everything's rotating around the center of the galaxy, because for the most part, that's pretty much the common theme. You know, whether there's rotations within that rotation is very important, but, and I'll touch on that later, but the point being is that when the star is in an upswing, it's producing more energy than when it's in a downswing. That means it's hotter, it's brighter, and it creates more energy. And so the planets that are around those celestial objects are going to get hotter during peak upswing, and they're going to get colder during the downswing. Okay, so I already explained to you what the peak upswing from 6 p.m., 5 p.m., 4 p.m., 3 p.m., 2 p.m., 1 p.m. That's generally the upswing, and you could call peak upswing right about 3 p.m. And then if you're looking at 12 o'clock, you have 11, 10, 9. That would be downswing, 9 o'clock being your peak downswing, okay? So the reason why I'm going to inject this little piece of information and about this particular part of the celestial mechanics is we already know on planet Earth there's a thing called climate change. You could call it global warming, you could call it climate change, you could call it whatever you want to call it. Now, we were talking about the age of the galaxy, and so then the question is how old is the galaxy? And let's just say that point is relatively irrelevant, okay? So how old is Earth? Earth is 4.6 billion years. Let's just call it 5 billion years, and that point can be contested, but let's just say that everything that we can measure from the surface to the deepest parts and the oldest parts, oldest rocks that we've been able to find, let's just say they're about 5 billion years old, give or take a billion years, okay? Now, so what becomes really important right here is understanding, and this is very important. This gets into all the biblical stuff that they talk about. There's a great year, 26,000 years. All of this is very, very important to the point I'm trying to make right here, right now. It has to do with climate change, has to do with global warming. It has to do with literally the mechanics that planet Earth, the mechanics of the sun, the celestial mechanics, the machinery of the cosmos, the things that Earth will experience and will go through and has gone through and has experienced, and the actual evidence of what I'm talking about can actually be looked up and verified. Okay, so that said, how long does it take for the galaxy to go through a complete rotation? So how long is a galactic year? A galactic year is estimated to be about 225 million years. Okay? So a galactic year is estimated to be about 225 million years. Okay, so if we look back a billion years, okay, that's 5 rotations. So a billion years ago is 5 rotations, okay? And this is going to get complicated, and you're going to have to listen to this, but this data is rock solid, okay? This is rock solid. There have been 5 extinction events and there have been 5 major ice ages. Okay, for all the little children in class, if you can raise your hand and you can tell me when were the extinction events and when were the ice ages? Okay, so it takes 100 million years. If you're at 12 o'clock, say the entire galaxy, say the sun is at the 12 o'clock position, and it goes from 12 o'clock to 11 o'clock to 10 o'clock to 9 o'clock. That's a downswing. Okay? How long does it take the solar system, the sun, the solar system, including the sun and the earth that we're in, how long does it take it to go from 12 o'clock to 6 o'clock? 110 million years? Bingo, you're right. Ding, ding, ding. You get a brownie. You get a star. You get a gold star. And that's, you get a 5-sided gold star. And I'll explain that even further. But it takes about 100 million years to go from from 12 o'clock to 6 o'clock. Okay? And then how long does it take to go from 6 o'clock to 12 o'clock? About another 100, so it's 112.5 million years. 112.5 million years equals 225 million years. That, of course, this is all give or take, 25 million years. So let's just round it off to the galactic year is 200 million years. 100 million years is on the downswing, and 100 million years is on the upswing. Okay? Is that clear to you? Now, looking back a billion years, we've had 5 extinction events and 5 ice ages. Can you tell me how long the last 5 major ice ages were? 100 million years. Did you find a coincidence? 100 million years. Each ice age lasted about 100 million years. Going back a billion years, each ice age lasted about 100 million years. Did you notice a coincidence? When the sun is, the solar system within the galactic rotation is on a downswing, okay, the Earth goes into an ice age. Motion of matter equals gravity equals energy plus about 10%. As the sun is moving slower through the Higgs field or the dark energy field or the ether or the piranha or whatever you want to call it, as the sun is moving slower in its galactic rotation, it cools down. When the sun cools down, the Earth cools down. When the Earth cools down, the ice caps and everything, all the moisture in the universe, in the world freezes, and it creates a giant ice age. It's all frozen, okay? Now, at 6 o'clock, okay, when the sun starts to go through its peak upswing, okay, you have all of the ice melting, and then biblical floods and who knows what else, okay? But you're talking from 6 o'clock to 12 o'clock is 100 million years. And, I mean, honestly, this whole cycle's, really, I mean, you're talking a billion years, within the last, I mean, a billion years is like unimaginable. 100 million years is unimaginable. 50,000 years is unimaginable. 500,000 years is all unimaginable, How long ago were the dinosaurs? 600, 700,000 years ago. It's all unimaginable. But what we do know is that there's been 5 ice ages in the last about billion years. There's been 5 ice ages who have all lasted about 100 million years. So they've all lasted during the peak downswing or during the downswing. And then we have 5 extinction events, and the data on the extinction events is a lot more vague, but my guesstimation is that during peak upswing, okay, when the sun gets really, really hot, okay, the Earth gets really, really hot, and basically the planet goes through a Mars on Earth scenario, very similar to Mars, literally the conditions on Mars, and a lot of the vapor, a lot of the moisture gets literally blown off the planet. The planet turns into a giant desert, radiation levels go out the roof, and there's huge extinction events. Do all the oceans evaporate? The answer to that is probably not, but we don't know 100%. Literally, if everything goes extinct, like literally if everything went extinct, I mean, life will bounce back. That's just the way life goes. The universe is a naturally occurring crystal core quantum computer. The sun is a naturally occurring crystal core quantum computer. The Earth is a naturally occurring crystal core quantum computer. As soon as the conditions become favorable for life again, life will reemerge automatically. Okay? But that's just further down the conversation. But the point is, the hard evidence is there that these celestial mechanics do affect the universe. They can be measured based on current science, that motion of matter equals gravity equals energy. That can be measured for sure. Now, the extra 10%, that gets even deeper and more complex because of the mathematical structure where everything is expanding. Expansion equals 11. You don't, it's hard to explain, but basically you're going to go from 10. You're not going to go from 10 to 10.001. You're going to go from 10 to 11. It's just kind of a quantum universe, and that's the way things work. And it's even harder to understand, especially when you start talking about time travel, where 10 is your reference point, 11 is into the future, and 9 is going into the past. Now that right there, you could just scratch what I just said. Just don't even worry about what I just said. Just forget about that, because that's going to fucking blow your mind, and you won't understand any of this, if you even understand any of it anyways. So don't worry about time travel. That I can tell you right now. But all I can tell you is that the universe is expanding. Motion of matter equals gravity, which equals energy. There are celestial mechanics. Within those celestial mechanics, upswing and downswing, the way the universe works and the way the celestial objects are moving around each other, that's very important. Okay, so I wanted to throw that in there. I told you that I'm going to interject this little piece right here. That was very important that I did that, because that's a key point that I have to put in there. Okay, and I'll do some more videos on that subject and talk about the great year, the precession of the equinoxes, and the 4 cycles within that, and the golden age and the iron age, and all this esoteric stuff, and the Taurus and the eagle, and what that really means. But the point is that we know for sure, scientifically speaking, the galactic year is, let's just round it off to 200 million years. 100 million of those years are in a downswing, and 100 million of those years, the Earth experiences an ice age. And then you have the other 100 million years where life bounces back. And then what happens is, after life has bounced back, you start to get into the peak upswing right around 4 o'clock, 3 o'clock, which is tens of millions of years in itself. But within this period, the Earth goes through a Mars on Earth scenario where basically everything turns into a giant desert. The oceans, if they don't boil off completely, they probably get very, very low. And most of the moisture on the planet gets literally blown out to space, and then reforms in the Oort cloud as giant, snowballs. But I just wanted to interject that point. Now, let me go back to where I was about 20 minutes ago in this talk. And what I was talking about is the central hub, the central black sun, the central black hole at the center of the galaxy, which is a pole for all the rest of the stars to use as a pole for them to spin around. And they work with each other. They use gravity assist, okay? And they spin faster and faster. Now, as they move out from the center and start moving faster and faster, and as they're literally taking the excess electromagnetic energy that they're able to produce because of this motion, they're able to take that excess electromagnetic energy, and within the structure of their matrix, they're actually able to take that excess energy and convert it into matter, okay? Now, there is this concept where there's the Gluon Field, okay? And if you start to take protons, or it's actually quarks. I don't remember if it's protons. I think it might actually, it doesn't matter if it's protons or quarks. Whether you're pulling quarks apart or whether you're pulling protons apart, the energy that is required to pull a quark apart, okay, it will start to resist, okay? The Gluon field will start to resist. And you have to know what you're talking, what you have to know some physics, otherwise I'm just talking, but blah, 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 blah. I might as well be speaking Martian, but you have to know some of these basics, otherwise you're not going to understand this. And I'm going to try to simplify it, and I'll try to explain it as I go. But so as you pull these subatomic particles, as you try to pull them apart from each other, okay, so you pull on the, let's just say we're looking at the quarks, which is basically the smallest part of the atom that we really understand, okay? And the quarks within the proton are held together by a gluon field, okay? Which is same thing as the Higgs field, except for the Higgs field, just like the universe divides itself into 10 distinct pressure gradients, okay? The Higgs field is the dark energy field, but just on a much, much smaller scale. And it's basically, there's really two forces. There's energy and dark energy. The point being is that when you get to the smallest, most fundamental parts of the atom itself, and those are protons, and then once you start to look inside the proton, that you see that there are quarks, and then those are like literally the smallest spheres that are inside the proton. Once you take these quarks and you start trying to pull them together, there's this field, okay, that's trying to hold them together. And as you expend more energy pulling these quarks apart, guess what happens? If you expend enough energy, you think, okay, it's going to snap and break and it's going to explode into this cosmic explosion. Nope, that's not what happens. What happens is that you create new quarks. That's what happens. So as you pull harder and harder on the quarks, new quarks are created. Okay? Now, I was telling you that there's 10 dimensions, okay? And when you're starting to talk about the quark, you're literally talking about the 8th or 9th dimension. Okay? As you're at that lowest dimension and you're pulling on the quark, it's hard to explain, but basically you're pulling energy from a dimension underneath us. So you're literally pulling in new energy from a dimension underneath us. And as you pull those two quarks apart, new energy is being pulled in from the dimension underneath us and creating a quark. That's where that energy is coming from. And guess what? You had two quarks, you were pulling on them, you were using energy. Say the spiral around the galaxy gives you, at the very center of the core of the star, it gives you that energy to pull on the quarks, right? Just like Saren's Eye, where you have these two pillars, okay? And you see this pulling, both pillars are pulling, and there's this black void of absolute nothingness, but energy keeps coming out of the black void of absolute nothingness, and it's burning, it turns into fire, and that fire is a representation of electromagnetic energy, which where there was no electromagnetic energy, now there is electromagnetic energy. It's magic, right? So you say, well, where does the energy? It's coming from a dimension below us, okay? It's the easiest way to explain it. You take the two most fundamental particles in the universe that we know of, and you pull on them hard enough, and guess what happens? They don't snap, and there's not a huge explosion. New quarks fill the void, okay? So new energy is being created at the very subatomic level of particles. That's what's happening. So as these stars, okay, as they're traveling, moving faster and faster through the dark energy field, as they're rotating around the central black sun, as they're spinning faster and faster using gravity waves, they're all teaming up together like a giant ballet. They're all dancing. They're all singing to each other with singing songs. Hi, Bob, how are you? I'm going to be going this way at this speed, at this exact direction. If you come along this way, you're going to speed up, and I'm going to speed up, and I'm going to slow you down a little bit, but then I'm going to speed up, and I'm going to go faster and faster, and I'm going to pass you. Then you can use that energy, and you can slingshot off of me, and Jill comes in. Hi, guys, I'm over here. I'm going to be going this way, and if you come around me, and then Jill meets Bob, and then Jill's like, oh my God, Bob, I love you, and Bob's like, Jill, you're so beautiful, and they start spinning around each other while they're also spinning around the central black sun. So that means that they're spinning even faster and faster than they normally would if they were just spinning by themselves. And remember, they're swimming at this point, so they're swimming faster and faster to infinity and beyond. That's the way the machinery works. The faster you move, the more energy you have. The more energy you have, the more mass you create. The more mass you create, the more energy you can produce. The more energy you can produce, the faster you can move. The faster you can move, the more energy you create. And then Bob and Jill are loving each other, and they're spinning and faster, and Jill starts getting bigger and bigger, okay? And then it gets to the point where Jill has gotten to this point where she has so much excess energy that she could literally throw Bob off and keep moving faster and faster, but she doesn't do that. What does she do? She takes that excess outer layer and she pops off and novas, okay? Boom, big explosion. Bob knows that she's going to be popping off, so they give themselves some distance, okay? They start spreading as they're spinning around each other, as they're spinning around the center of the galaxy, and as all their friends are spinning around them, everybody contributing to this excess motion, okay? The galaxy doesn't stay static. It's constantly expanding. So, say it was 100 stars, okay? Jill starts to get bigger and bigger, and she's big, fat Jill. She pops off, has a nova, loses, say, 25% of her mass. But guess what? Now, all of that gas around her, she can actually use her vibrations, okay? She can actually use electromagnetic vibrations, and she can actually start taking that excess mass, and not only will it have a tendency to want to form together because of gravity alone, but she can actually assist it. She can actually start assisting the big giant, basically planetary nebula or stellar nebula that's surrounding her, she can literally start vibrating it harder in one direction and vibrating it softer in another direction, vibrating it harder here and vibrating it harder in here, and literally like grabbing your hands and taking putty and molding this energy into these celestial objects, and she can literally start to create planets or small stars around herself. And then now she has her own galaxy, she has her own solar system. So now she has an entire solar system around her, and she's still waltzing with her husband. I forgot his name. So Jill and Bob, yeah, that's right. So she's still dancing with Bob. Bob has gone out quite a ways to give her some space while she has this solar system around her. Okay. And then that solar system, those little planets and stuff, she compresses these different balls, okay, using her actual mind and physically being able, I mean, you're talking about over millions of years. This doesn't all happen in the course of me and you sitting at lunch and, taking a bowl of lettuce and crunching it up and saying, oh, here we go, here's a new planet. What we just did over lunch, what it takes her to do that, over the course of millions and millions of years. But eventually she takes these, she's actually able to guide the mass into these lumping objects. And then with her vibrations, she keeps them into a spread out orbit. Those planets and stars start rotating around her. The stars, the smaller stars, go through a planetary nebula, and they create planets around themselves. The planets, believe it or not, can actually get big enough where they create moons around them. And they create, actually what they do is they start to create rings around themselves, and then those rings, they can take the energy that the rings actually feed the planets, okay, and at the same time those rings, they can coalesce some of those the clumping matter within those rings and create planets and create moons. I'm sorry. So you have this whole hierarchy of Jill and Bob. Jill had a stellar nebula. And then within that stellar nebula, a whole bunch of stars were born. And then within that star cluster, a lot of stars popped off and had planetary nebula. And then eventually those planets got big enough and were actually able to create moons around themselves. And this is happening not just with Jill and Bob, but as this entire system is rotating and moving out away from the center of the central black sun, this whole system is happening in multiple points throughout this galaxy. And the galaxy is literally growing larger and larger as it's moving through the ether, okay? And so it's a fractal. You literally have a fractal. You have a fractal of the galaxy within the star cluster, and then you have a fractal within the star cluster. You have solar systems, and then you have a fractal within the solar systems. You have planets, and they have their own little tiny solar moon systems or planetary, whatever there's no name for it. The name that has been thrown out there for all of this stuff, once a star has the solar system, it's called a galaxy. And there's only one word. It's a galaxy. So the star has a galaxy, then the planets have a little galaxy. But anyways, let's just we got to name these things. There's no names. This is all, theoretical. It's not theoretical. This is what's actually happening. But we don't have names for it. So it's all, revolutionary or modern or whatever you want to call it. I don't know. I'm not like, I don't have the names for all these things. Okay. But anyways, so that's what's happening. You have the star, Jill and Bob spin around each other. And the reason why they do that is because if they spin around each other while also spinning with all the other stars, they're spinning much faster than they would if they were spinning by themselves. So they're able to team up and actually create an excess of energy. And then Jill and Bob. Jill has a stellar nebula, and the stars have planetary nebulas, and that fractal, that whole fractal right there, is repeating in multiple points throughout the galaxy. The galaxy's spinning around the galactic cluster, and over billions of years, this galaxy is progressively getting larger and larger and larger. And of course, there's all kinds of dynamics. Within the machinery of the cosmos, within the singing song, they call it the singing song. All the stars are singing to each other in heaven. Oh, They're all telling each other how they're going to be moving, how they're going to be, you know, rotating, and they all work with each other to help each other move faster and faster. And literally the concept is swim, swim, faster and faster to infinity and beyond. Eventually, some of these stars, as they start to, well, first of all, there's new stars getting heavy enough where they literally create black holes, and they don't have to be on the outer edge of the galaxy. But let's talk about the stars that are on the outer edge of the galaxy, just because that's a point that I want to throw in right now. So as this whole galaxy is rotating and rotating, it's getting heavier and heavier, bigger and bigger. New energy is being created all the time. There's new black holes being created everywhere throughout the entire system. And there's these huge, huge, heavy celestial objects on the outside of this galaxy. Because remember, if you're at the center, if you're spinning around the galaxy near the center, you're moving so fast through the ether or the dark energy field or the Higgs field or whatever you want to call it. As you start moving out further and further away from the center, you're progressively moving faster and faster and faster through the medium, through the Higgs field, through the dark energy field, whatever you want to call it. Let's just call it the ether. I'll just call it the dark energy field because that's the name I call it, okay? So as you move out faster and faster, as you move further and further out from the center of the galaxy, you're moving faster and faster and faster through the dark energy field. That means you're creating more and more energy. You're getting heavier and heavier and heavier. You're increasing your mass more and more and more. And there is a point, you don't have to explode. A star does not have to explode to become a black hole. All it has to do is start moving fast enough, and there will be a point where the star can literally be moving fast enough, and just like that, with the snap of a finger, it will literally disappear and it will become a black hole. It does not have to nova. It doesn't have to supernova. That is a misconception. There is all kinds of celestial mechanics. There's all kinds of people, the way people live and die. The diversity of life on Earth is just as the diversity of the way the celestial mechanics plays out is just as diverse as all life here on the Earth. So there are, you know, C-sections, you know, there's all kinds of, you know, weird things that happen where the planet will nova and then the original star will collapse into a black hole, or it will turn into a neutron star, or it will just go from like a giant red dwarf to a white, a giant super red, I forgot the name of it, like some kind of red giant into a white dwarf or whatever they call it. So there's all kinds of different transitions and, you know, butterflies and, you know, caterpillars and all this other stuff, right? But the point being is that you don't have to nova. A star does not have to nova to become a black hole. You know, depending on the circumstances and how risky the star wants to be, where if it novas too early, it could actually, you know, it could cause it to have serious problems, but that's not the point. The point is that towards the outer edge of the galaxy, okay, these super heavy, massive celestial objects create black holes, okay, and then they really start to create new energy within themselves, and they literally start to grow galaxies. So at the edge of the galaxy, you have these supermassive black holes literally popping off, like literally out of nowhere. There's no star, there's nothing, all there is a black hole, and then all of a sudden it just novas, boom, this huge explosion, this huge mass is generated seemingly out of nowhere, okay, which is magic itself. This huge, on the outer edge of the galaxy, this huge hype supernova, superluminescent supernova occurs, and the black hole is actually able, just like the star was able to take all that mass and form it up into a stellar nebula, and then, so the supermassive the black hole at the edge of the galaxy does exactly that. It novas, it creates this huge, you know, celestial nebula, which then eventually slowly starts to actually create its own, I guess you would call it, galaxy, and then that galaxy literally gets flung out from the galaxy that it's in and creates a new galaxy. So not only did the galaxy, at the center of the galaxy is the black hole, which is creating an infinity of new black holes inside itself, but it's also spitting matter and energy, constantly spitting matter and energy up, creating the galaxy around itself. But eventually those celestial objects that it created, eventually, as they get out towards the edge, they get flung out and create new galaxies of their own. And so you literally have infinity. You have the machinery of the cosmos creates a multitude of infinities. I mean, it's just pure infinity, and all of this new energy is constantly creating higher and higher energy states. And at the same time, all of the matter in the universe is decaying. So all of the matter in the universe, all the stars, all the black holes, all the atoms, everything in the universe, depending on its point within the 10 distinct pressure gradients, the 10 different Higgs fields, the quantum gravity, whatever you want to call it, within, depending on its modulation and all this other stuff, everything is decaying to some degree and creating new dark energy. Okay, so when matter decays, it goes from energy into dark energy. That is literally the mechanism that is growing the universe that all of this machinery is housed in. So not only is all the machinery creating new density within itself, it's creating an excess of energy outside of itself. All the stars, when they're glowing, that bright white glow that they're giving off, that the matter that is going from the iron crystal, iron, gold, plutonium crystal core that is the matrix of the star, as that material slowly starts to rise towards the center and starts to literally decay, moving up the elemental chains from iron through to, you know, copper, nickel, you know, helium, not helium, but neon, calcium, up through to the helium, and then eventually hydrogen. At the very surface of the star is the hydrogen layer, okay, the lightest elements. And as those hydrogen elements move out and decay away from the star, the way the time works, as they move out away from the gravitational influence of the star, they literally start to increase their time. The material starts to increase its time. As it increases its time, it increases its energy. And so there's this perplexing concept in stellar mechanics where when you look at the surface of the sun, it's 10,000 degrees, but the sun's corona is 250,000 degrees. How could it be that as material leaves the surface of the sun at 10,000 degrees, and as it moves and it expands outwards, it actually heats up? On Earth, when gas or matter, or liquid or gas, whatever, when it expands, it does not heat up. It does the exact opposite. When matter or gas here on planet Earth expands, it cools down, okay? But when you look at the sun, the surface of the sun is 10,000 degrees, but the sun's corona, that outer atmosphere that surrounds the sun, is 250 million degrees, or whatever it is. It's like 10,000 times hotter than the surface, okay? So how could that be if there's a gas that's moving up and away from the sun, but it's not getting cooler, it's getting hotter? That's because its time is increasing, okay? Because its time is increasing, its energy is increasing. When its energy increases, the rate at which it decays increases. The hydrogen converts from hydrogen into light itself. So it started off as, let's just say, iron as the base, even though we know inside the iron core there's denser and denser and denser elements. Apparently, there's 266 elements in the universe, okay? And anything denser than that creates a new universe. We don't know about them. We only know about 115 elements, and then anything denser than that, we just can't create it. We don't have the machinery to compress matter hard enough to create a dense enough element. It doesn't, we just don't have that technology. But inside the cores of the planets, after the vast majority of the core itself is iron, at the very center of the iron core, you start to get denser and denser layers of elements, ranging from plutonium, uranium, 115, 123, and then it goes all the way down to 266 or 265, 266. I mean, basically 250 and beyond, whatever it is. Now, there's an interesting thing here, and I'm just going to throw this out here, and it might be a sidetrack, but iron is 26 on the periodic table. Gold, okay, is 79, which actually, if you look at it, you have iron, and then iron times 3 equals gold. Okay, I just wanted to throw that out there. Now, iron times 10 equals 266. Okay, so there's definitely, they call it the periodic table, and it's a chemical. There's literally, just like you have different frequencies, literally in the electromagnetic spectrum. If you look at the way chemicals are arranged, there's literally a different octave or a different frequency for each chemical element. As it gets denser and denser, it has a different octave. It's literally like a staircase, okay? I just wanted to throw that out there. It's quantum. That's why they call it quantum. It's a quantum universe. And if you know about science and mathematics, you understand what I'm talking about. But so anyway, so the point that I was making is that I just wanted, I find it very interesting that you have iron, which is 26 on the periodic table, and then gold is times 3, which is iron, and which there's some importance to that, which I might elaborate on this talk, or I might talk about it further in upcoming freeform chats. But okay, so I gotta speed this up because it's getting quite long. Okay, so anyways, so you have once you have the iron core, okay, once you have the iron core, the star primarily starts out as primarily an iron core with, you know, and then you have the denser and denser elements within the very center of that iron core. It gets denser and denser, almost like a jawbreaker of different denser and denser elements going, you know, whether it goes to 266 or if it only goes to 130 or who knows what the exact number is. It doesn't matter. We know that there's iron, and then once it gets denser and denser in the core, you have this new matrix of elements, and they become radioactive, highly radioactive. They start generating their own excess energy, so it's radioactive crystals in the core, create the crystal core quantum computer. And there's a whole matrix of all of these elements forming up that create the intelligent part of the crystal core quantum computer and the actual consciousness. And so I forgot exactly where I was, but okay, so we have the spiral of the galaxy, and as it gets larger and larger, and Jill and Bob have their stellar nebula, and the stars have their planetary nebulas, and then eventually there's a really heavy black holes on the edge of the galaxy, and they get flung out. They have supernovas and create new galaxies of their own, and you have the supermassive black hole at the center of the galaxy is creating a new universe, which is creating black holes, which create new universes infinitely, and then all of the matter and energy. Oh yeah, that's where I was at. All of the matter and energy in the universe is decaying at some rate or another, and that decay is the matter converting from energy into dark energy, and the dark energy is literally the medium that the universe is made out of. So if the entire universe is growing, and if that entire universe is growing fast enough, that medium is under pressure, and there are points where there's a pressure release, and that excess energy gets popped up into the universe above us, and there's a supernova in the universe above us, and all that extra dark energy, and it could get more complicated. It could be that there are some black holes that literally get expelled from their galaxies, and then those black holes, here we get biblical, but those black holes that, you know, they're not cooperating with all the stars that are singing to each other the singing song, and they're all dancing and they're all having fun, and they're basically, you know, angels in heaven singing the singing song. And there are some characters within this whole system that are just jerks, and they're just assholes, and they try to suck people's energy and get ahead. And, you know, after millions of years of all the stars singing with each other, they start to realize that there's these jerks that keep trying to suck people down. I mean, it's literally, you know, there's no words. It's like literally the guy is like trying to cut people off, and he's slowing people down, or he gets too close to one star and literally gobbles it up. And all of the singing stars get together and they say, this guy's a freaking jerk. Let's kick him out. And they all work together to literally use their gravitational assist in the gravitational waves, and they literally throw him out to the edge, whether he explodes and creates a new galaxy of his own, or if he doesn't do that, he starts to shrink and shrink and shrink, and eventually he gets too light for the universe that he's in, and he literally gets spit up out of the universe he's in, and he is now a fallen core. Okay? He is now fallen. He was spit out of the black hole into the universe above us, and he has been fallen. That he has literally fallen out of the universe he's in, and he's popped up into the universe above us. Okay? And if you understand about the fallen angels, now what is this celestial object that popped up above us? When he popped up, okay, first thing he probably did was nova'd, okay? If he survived the nova, okay, and he somehow stayed alive, he was massive enough to survive getting popped out of the universe that he was in and literally spit up, first thing he's going to do is probably nova, okay? So he's already going to be contributing to the universe above us in some extent, okay? Now, but the thing is there's that consciousness in the core of that central celestial object, whether he remained a black, he probably was not able to remain a black hole. Okay, that's for sure. Whether he became a neutron star, okay, that could be very high probability that he became a neutron star, and then he could have absorbed, and that nova that he did, where he popped off as a neutron star or as some kind of massive celestial intelligent, highly intelligent object, he could have gobbled all that material up and turned back into a black hole. Okay, so now he's this black hole that doesn't like to, cooperate with people, and now he's at the center of the galaxy in the universe above us. So he's the fallen. Now he's the fallen. And is he going to cooperate now with this new group of celestial objects that are all trying to spin faster and faster so that they can create black holes and have universes of their own to infinity and beyond? Or is he going to be a jerk and try to cut everybody off and eat as much as he can? So here he is, and here's this fallen, and he's a highly intelligent creature, okay? And is he cooperating with the rest of the universe, with the rest of his galaxy, or not? Does he learn his lesson or not? Who knows? Let's just say he didn't. He's still an asshole, okay? But he was able to nova, and then he was such a jerk that instead of actually building a whole stellar nursery around him, he literally cannibalized all his children, okay? He ate all his children to sustain him, and now he's a more powerful celestial object than he would have been. If he was actually smart, what he would have done is he would have taken his nursery, and instead of cannibalizing his children, he would have worked with his children to start moving faster and faster and cooperated with them and cooperated with the rest of the galaxy that he was in to join the movement, to join, to lock arms with all his comrades, and he would have, been able to grow and expand, but that would take too long. He wants the fast way. He wants the fast way. He doesn't want to cooperate. He just thinks that he's going to get the fast. And so they kick him out of that galaxy. And there he is. He's now popping up into another galaxy, and he's fallen again. How many times he can fall? To be honest with you, because everything in the universe is either expanding or contracting, there is a possibility that after he novaed, whether he was actually able to eat his children or not, and actually start moving fast enough so that he doesn't continue to shrink. Because remember, everything is decaying. Everything in the universe has a tax to pay to the dark energy field. Okay? So, if he novaed and he created a stellar nursery around himself, and they got away from him, or, he did eat them, but everyone saw what he did, and they're like, we're not going to join up with you. We're going to push you, we're going to push you. We're not going to help you, and you're going to start to slow down. And as you start to slow down, you have a couple of options. The black hole's going to eat you, and when it eats you, you're not going to have the same power and control you do right now. Okay, you're gonna go through entirely different phase. Okay, you're gonna go from being basically a god of your own universe to now being just an entity within the universe that just ate you. Okay, or he won't eat you. He'll just somehow, with the cooperation of the rest of the galaxy, just slowly start to push you away into a point where you cannot keep moving fast enough. If you can't keep moving fast enough, you're always paying a tax to the dark energy field. You're going to start shrinking. You're going to shrink and shrink and shrink, and you're going to hit that Planck scale, and you're going to be going bye-bye, okay? And of course, he's going to have tons of opportunities to nova, get smaller, and he still could have the potential to create a nursery around himself, and then, use that nursery to create enough energy to catch up to the rest of the galaxy, to get on the rails, okay, and to get with the program, and to start spinning, so he can start spinning faster and faster and start building his energy. Or he's going to start slowing down, all the while decaying and decaying and decaying until he gets kicked out of that universe. And eventually, it's going to get to the point where he doesn't have enough mass, and he will literally evaporate into nothingness eventually if he does not get on the rails. And these these demonic fallen, they know this. The problem is that they know this. They know that they can go be dickheads for a very, very, very long time. They know that. They know that as long as they have a single piece of golden grain of sand, that they have the potential to get back onto the program, to get on the rails, and to get back into the game. And they're going to just shrink and shrink and shrink and shrink. And they know that the rest of the universe, once they get down to the size of a grain of sand, because people are loving and people are loving and caring and forgiving, they will forgive him, and they will say, come on aboard. You're a little tiny grain of speck of sand, but you can rotate around me fast enough so that you can, you know, get a little bit larger and a little bit larger, and it's going to be eons and eons and eons will pass where you're big enough to become bigger and bigger, and eventually, you know, I mean, I'm just using grain of sand as a metaphor for the size. But this is known. Though there's also the possibility that everyone says, no, you've been such a jerk for so long, for so many universes, you've fallen and fallen and fallen, and we're not going to help you, and we're going to let you wither and die. In fact, this is where it gets really freaking crazy. When a universe, when a core, when a crystal is in that state where it's basically been rejected, that crystal is allowed to be harvested. There are life forms that can literally find a crystal like that is guaranteed to shrivel into nothingness because it's been a jerk. And they can say, they can talk to God at the center of the galaxy and say, hey, God, let me just ask you a question. This guy here, he's been a jerk. He was inside 3 of your universes. He got progressively kicked out of each universe. He's lost so much mass and so much energy. And now he's sitting here, and there's no way for him to return. He's still a crystal core quantum computer. He's still got a lot of power, but he's not going to join the rest of, he's not going to get on the rails and join the rest of the spiral, and he's not going to gain, you know, grow, and he's going to hurt the galaxy because he's going to shrivel away into nothingness. Let me ask you a question. Can I break his event horizon, harvest his crystals, and then use him to, say, grow a population on my planet, or to play cards with my friend, or to put him on my ring? I want a pretty ring. Can I take that guy right there and put him on my ring, my little magic ring, or put him on the centerpiece of my crown and create a magic thinking hat for one of my humanoid bodies on one of my planets? And God looks at him, looks at, you know, say the guy asking permission to harvest that crystal, says, you know what, that guy's been a freaking jerk for 3 universes. He's done nothing but trouble. Go ahead, harvest him. Guess what? Somebody's got a new shiny ring or a beautiful new crown on their head with a, they've got this new magic thinking hat with this crystal quantum computer embedded in a gold and silver and, you know, whatever other, you know, metals, precious metals, maybe with a couple of emeralds and a couple of rubies. And this guy says, okay, I'm going to play a game on this planet where this crown makes people, you know, the leader of all the people on the planet. And God says, hey, I'm going to have fun with that one or twice. I'm going to go and incarnate on that planet and play a game where I'm going to jump into that planet and try to get that crown and see how long I can play it without getting killed by, you know, some other person trying to get the crown from me. And we'll play flesh games on one of your planets. And that little crystal crown right there, that'll be a fun game to play. And so the fallen get harvested. And that's the way the life works, man. That's the way it is, from the celestial mechanics all the way to the fractal of, you know, human behavior. And I'm going to end my talk right there, and I'm just going to say right now that that's the way the universe works, and there's a lot more to come. So stay tuned. If you thought that was a roller coaster, wait, that ain't you ain't seen nothing yet. Thanks for watching. If you like this type of content, feel free to subscribe and give me a thumbs up. Ask questions if you have any questions, and stay tuned because I will be going down the rabbit hole more. Thank you.